sorry. So you have these, you have these different device drivers at the bottom, and then you have a generic block layer, because at the end of the day what you want to deal with is basically megabytes and gigabytes and kilobytes of data. You don't really care about, well, how does the SSD sh- b- b- construction internally is, how is it internally as a piece of hardware, or how is it different from your USB device. You might care about this if you're an electronics engineer, but for most, even programmers, they just care about their speeds, right? And the size of the hard disk. So you have a generic block layer that basically translates this, whatever lies at the bottom, to megabytes, kilobytes, and so on. You have the file system on top that basically has, what is a file, what is a directory, where, how are they linked, and so on. And you have the application on top running and reading and writing to that. So one thing that we have to notice, that having this very generic, very abstract model for the different devices means that you cannot really have a lot of specifics for each device, right? If at the end of the day all devices will have a command, data, and status bits, you cannot really play a lot with these, right? So some devices, some hardware devices, have actually lots of internal capabilities that become unused because, well, if you're using the generic device driver, then there's no way to expose these hardware capabilities. So one example for this is that the SCSI devices, which have very rich error reporting, they do not really get exposed easily using the operating system. You can actually expose them using other, there's like what they call the SMART tools and SMART tools that actually tells you things about how, if the hard disk is failing and so on. But that's actually an extra top over the operating system, an extra layer over on top of the operating system. So this is one problem with this. Also, there is a problem with device drivers, is that since there are thousands and thousands and probably almost billions now of different devices on Earth that you would want to support in your kernel, that means that there is a bloat in the number of device drivers that come with the kernel. So Linux has almost 70% of the code of the total Linux kernel code, the whatever 400 megabytes or 1 gig, 1.2 gigabytes of data that you download when you get from GitHub. 70% of that are device drivers, and many of these device drivers you will never use actually, because you probably, I mean, some people will even not use Bluetooth, for example. I mean, for a really dumb example, many of the, so my laptop now does not come with a CD-ROM, but nevertheless, my Linux installation or my Windows installation does come with the device drivers for the CD-ROM, although I don't have it, right? So I mean, I'm not going to use it. So a lot of this code is actually inactive. Another problem is that many of the device drivers are often written by non-kernel programmers, basically people who get employed by some company, and that company produced the latest and greatest mouse with 20 buttons, and they want you to write a device driver, well, not you as a person, but others who have not done their LKM project. So they want them to write a device driver, and they're like, okay, how do I do that? And they go googling and stuff. So it's not really part of their day-to-day job, which basically means that these device drivers are actually flaky. They actually cause, in many cases, the kernel to crash.